Alright, hell yeah. So when you do math, there's two modes that you can be in. One is like puzzle mode, and that's what we're going to show today. Like, it was just, when I was in puzzle mode, I was like, hell yeah, 15 times 25 is like, well, I know multiples of 4, you know what I mean? Like, four $25 bills is 100. And then so if I can see multiples of 4 in the number 15, well, hell yeah. And then obviously the closest multiple of 4 is 16. So this has to be very close to 400, and it's just 400 minus a $25 bill, so this is 375. So that's puzzle mode. But I bring up this video because like one of the hardest things that I always struggled with was like lab work, because you still have to use like there's a disconnect between having a calculator, pen, and paper and sitting at a desk and being in puzzle mode where you can see those connections. Where when you're out in the field, sometimes you just have to use like a different strategy, because my mind goes to potatoes. So one of the strategies that I use for this one, and I did it in a different video, is like, hey, 15 times 25, what I know from this strategy is pretty cool. I can increase this by 5. I can increase this to 20. And I can decrease this to 20, you know what I mean? And so if I increase this by 5 and decrease this by 5, now I got 20 times 20. And I know that this answer, it's not exact, but it's going to be approximately 400. And then I also have done this quite a bit, where if these numbers are closer to 5, like if I have 45 times 55, it's like, oh, hell yeah, we're just money. Compared to... yeah, so let's check this. Let's check the error between this one, and then we're going to do 95 times 85, and then we're going to do, and this is the lowest. This was off by 25, you know what I mean? We were off by 25. But if we do 45 times 55, with that same strategy, we're going to be 50 times 50. 50 times 50 is going to be, see, even I struggle with that one, because the 5 times 5 is 25, we got 2 extra zeros, so that's 2,500. Booyah. And what's the exact answer on this? Well, should we try to do it mentally? See, yeah, I'm not in puzzle mode. I'm in field mode right now. I cannot do this. I don't know what the hell trick I would use. I really can't see it. Oh, here's a trick that I would use. 45 times 50. I get in this habit of saying like, oh, I don't know it. But the next thing that I do know is like some multiple of it. So I'm going to say 45 times 50. Don't know it. But I do know what 45 times 100 is. That's going to be 450. But yeah, I see it even messed up there. It's 4,500. You know what I mean? So my biggest mistake is actually just getting the factors of 10 off. But hell yeah. And I'm sorry. So I don't know what 45 times 50 is, but I do know that 45 times 100 is 4,500. And so that means that 45 times 50 is half of 4,500. That's going to be 2,225. I'm just going to write that, 2,225. Cool. And then, again, I don't know what 45 times 5 is. But I do know what 45 times 10 is. That's 450. But then half of that is 225. So I'm going to have 2,225 minus 225. And so the actual answer, I don't think I could do that mentally. But so we got 50, we got 4. So 2,450. See, and we're off by, we're off by 50. But with this one, our answer was way bigger. So our percent error, I think, is less when these numbers are closer to a factor of 5, you know, kind of in between the number line. And so, damn it, I guess we're going to have to probably finish this video analytically, because what is the percent error here? The percent error is where you take the number that we got, 400, minus the actual answer, 375, divided by the actual answer of 375, times 100%. So that's going to be 6.6% error. I'll slow down on that percent error. I just do it so much. But even that, a lot of people don't know the percent error calculation. So let's do it for this one. 45 times 55. We have the actual answer of 2,475. I even got the answer wrong. Damn it. Yes, because half of 4,500 was 2,250. So this is 75. I see my error. Okay, so this is the actual answer. And then what we guessed was 2,500. Oh, check it out. So we're actually only off by 25 again. You know what I mean? And we're only off by 25, and our numbers are way bigger. You know what I mean? So our percent error is taking our guess, 2,500, subtracting the actual answer, 2,475. So this gives me the difference. Now I'm going to divide it by the actual answer, 2,475, and multiply it by 100, and we get 1% error. So our error there is 1%. Our error on the low end was 6.6%. Let's see what it is on the high end. And for this one, you know, I'm in lab mode. I would just have to guess this. That's what we're doing. It's 90 times 90. And honestly, the thing that I actually get wrong is the number of zeros. So I should really, before even doing this, say this is 10 times 100 times 100. And it's very good to go to scientific figures. 10 to the 2, 10 to the 2. This is 10 to the 4. And then it's good to know your scientific figures. 10 to the 4 is 10,000. You know, because it's 1 with 4 zeros. You know, 10 to the 5 is 100,000. 10 to the 6, you know, those markers. 10 to the 3 and 10 to the 6, I'm sure those are markers where, hell yeah, that's 1,000,000, this is 1,000. 10 to the 4 is probably the hardest one for me to see. 10 to the 5, I've actually used that one quite a bit, 100,000. I used that more than 10 to the 4. All right, hell yeah. So, polish off this video. So hell yeah. So this is going to be an answer that's close to 10,000. So when I multiply 9 times 9 or 90 times 90, I usually make an error and say this is just 810. You know what I mean? 9 times 9 is 81, and then just throw 1 0 after it. So I need to catch myself all the time on that this is 8,100. But booyah, by doing that preliminary guess, I can see that 8,100, if I said 810, well, hell yeah, that is nowhere close 10,000. It's nowhere close 10 to the 4. So sweet, so this is my guess for this, and we're going to go 85 times 95. The actual answer is 8,075. Okay, so, oh, this is fascinating. So actually, I learned something today that I did not know. I thought if the numbers were closer to the midpoint that they would be more accurate. But now I can obviously see that, hey, 99 times 98, you know what I mean? Or like 99 times 99, and if I increase these to 100 times 100 as a guess, that's going to be way more accurate than taking... what would I take? You know what I mean? Just 2 times 2, and then shifting this either direction. You know what I mean? Saying it's 1 times 1, or it's 3 times 3. You know what I mean? Both scenarios, we just increase this number by 1. Now, what we're doing is we're increasing a number and decreasing a number. So if I compared 1 times 3, where I would increase this to 2 times 2, and I compared that to 99 and 97, you know what I mean? Where I would decrease this to 98 times 98. Well, 98 times 98 is going to be hella accurate, where 2 times 2 is nowhere close. Like, look at this. This is, the actual answer is 3, and then our guess is 4. Where here we got 25 seconds, and that's all we have. So it might just end abruptly. But hell yeah, 98 times 98 our guess is 9,604. The actual answer, 97 times 99. We're only off by a 1. So if we're only off by 1 and this number is huge, our percent error is just way low. All right, hell yeah.